So we have a really great, interesting group of panelists here. I think maybe we should start off with a few introductions. If you can just go down the line and say what you work on, if you're into cyber investing, what companies you have invested in or advise, and just to kick up the panel off, what do you see is sort of the next big thing in cybersecurity technology? Ido, do you want to start?
Sure. So I'm a founder at CTS Labs. It's a security research company. We do vulnerability research in hardware, and we also do consulting for other companies. We're very much focused on semiconductor. We look for processor vulnerabilities and vulnerabilities in chips. And I think this is becoming a foundational issue in many parts of the cybersecurity industry. For example, whenever new processor vulnerabilities are discovered, it becomes a foundational problem for cloud providers. It becomes a way for attackers to get into systems like the ones that we're discussing here. So I think that's definitely a big area of focus in the coming years and already.
Hi, my name is Andrew Channon. I come from the world of exchange-traded funds, and the way I like to look at ETFs is a way to kind of capture a theme that investors are looking to get exposure to, but by giving them a diversified approach, by allowing them to invest in multiple companies all at once and get instant global diversification. Most recently, for my company ProcureAM, we launched our first ETF last month, and it is the world's first space-focused ETF. The website is procureetfs.com. They have all the disclosures, but the fund name is ticker UFO. And I think that space is absolutely an imperative place that security needs to keep up with. And a lot of people have been asking about my sneakers. These are the first collaborations with Nike and NASA, so it kind of ties together the whole space theme.
I'm Mike. I don't have fancy sneakers on today. I lead security for Google Cloud. We have 46 cloud security products that serve enterprises around the world. Prior to this, I was the Chief Security Officer at Goldman Sachs, responsible for the consumer and commercial bank. My view is that as enterprises start to realize that the cloud could be interesting for a few use cases, they'll start to modernize in place. And ideas that are being used today in the cloud to secure cloud workloads will secure the on-prem environment in a similar way. So the models in the cloud will move to on-prem as well.
Hi there, I'm Ashley Asayan, and I am joining you guys today from Revolution Growth. We're a venture capital firm down in DC, Washington, DC. We've got about $1.5 billion under management, and we were founded by Steve Case and Ted Leonsis, the guys that founded AOL. We've got a number of investments. They're all really centered around this idea of tech-enabled business models, disrupting industries, and using tech to change things up and give consumers at the end of the day more choice, control, and convenience. So we're in things like Convene, which is the facility we're in today. They're working with landlords to provide hotel-like amenities to offices and co-working spaces, things of that nature. We have a number of investments in food and food technology. So we're investors in Sweetgreen. You might have seen an article on Inc. about how they're actually really thinking about that as a tech company. And then the balance of our portfolio is really around companies that are using AI and machine learning to do things in a way that adds more value when humans are actually touching things. So we're in things like Tempest, for example, based in Chicago. They are using AI machine learning and natural language processing to combine clinical and molecular data to help solve cancer. So we're really starting to see companies that are in these sectors start to deal with challenges related to cybersecurity. So I think this is a very timely panel.
Excellent. So Ashley, you mentioned AI and machine learning. I'd say that about 2 or 3 years ago, if you talk to companies about AI and machine learning and cybersecurity, most would probably say, oh, that's 5 to 10 years in the future, or at least real AI. And I feel like nowadays, I probably hear 5 times a day from startups. So we're using AI, and if I have a conversation and the word AI doesn't pop in the first 5 minutes, I feel like something is going wrong. What happened? Is AI here, or is it marketing? And what's the impact that it will have on cybersecurity?
On cybersecurity, for sure. Well, so I'll talk about it in the context of another one of our portfolio companies, Clear, which some of you guys might use at the airport, which is a godsend. You should subscribe if you haven't. But at any rate, so Clear, for example, they're storing biometric data. They're using tech to change not only the way that we're looking at access in airports, but also we're expanding that to sports venues and theme parks and other things of that nature. Where that becomes dangerous is, now that facial recognition and biometrics and things of that nature are propagating, it'd be really easy, for example, to spoof a biometric such that it doesn't recognize a certain face that's on a watch list coming into a particular building or facility. So, I think that there's a lot of applications in particular with both AI and with space technology where you're starting to see a convergence of physical and cybersecurity in a way that we haven't seen before.
Excellent. Other panelists, do you agree, or do you think that AI might be overhyped, or where do you stand?
Sure. So our company does quite a bit with artificial intelligence. We have several security products that use artificial intelligence to help solve the security problem. It's not necessarily using artificial intelligence for security in general. So I think that distinction is very important. So a good example of this, we have a product that does data loss prevention. So you can find names, addresses, other personal information, images of faces, these types of things, all automatically, and redact that information in almost near real time. That's a very different problem than, hey, we have a security operations center, we want to make that security operations center more efficient, we're going to use some machine learning to help address that challenge. I hear that use case a lot when it comes to automation or reducing the number of people that are required to do cybersecurity, and we saw some statistics earlier today on that. My view is that you need to use AI against a very specific problem that's already being addressed, and kind of fall in love with the problem. Don't fall in love with AI. It's in some cases a solution looking for a problem. But if you can get a really nice, well-contained problem, then AI can be very beneficial to solve that problem. And they're typically of the form, there's lots of humans who are reading data in a standard format, and you need to do something mildly interesting with that data and then spit out a result or perform an action as a result of the data. Does that always flow into a security operations center? Can you reduce the number of security operations center personnel by doing this? Probably not. You probably need to combine them with artificial and machine learning products to make them more efficient. We still need lots of people working in security operations centers.
And just to follow up, can you give some examples of those problems, the security problems that you think companies are going to start adopting AI to solve?
Sure. So we mentioned one today, which is around detecting sensitive information and treating it well. We think this is an important area. Matching up and determine and this is kind of a historical one that security companies have been going after for a long time. Just finding anomalous activity in log event streams. So this is something that, if you've got huge piles of data, it's very important to be able to find patterns in a much better way, which is a good machine learning solution to the problem. And then determining if content is malicious and for fraud and abuse purposes. So there's lots of great startups today using machine learning and larger enterprises that are using machine learning to detect inappropriate logins, to detect accounts that have been taken over. These types of topics are rich because you get lots of input data, and you can draw the success-failure curves over each other in a way that works.
And sorry, another follow-up. Since I know that a lot of people in the audience might not have a technical background, can you describe how AI could be used to sort of detect fraud and malicious behavior? What exactly is going on behind the curtain?
Sure. The typical way this works is there'll be a training set of activity that is known good activity, and then a training set of activity that's known fraud. And there are signals that indicate whether that are describing all of those activities. So things like What IP address is it connecting from? How many times is it clicking per minute? And you can imagine all of the potential signals. Those are driven into a model. Then machine learning, so machine learning algorithms drive those models to a prediction model. And then that prediction model effectively gives you the answer that you would have drawn on your own had you looked at the data manually as a human. So it's automating the process of taking lots and lots of signals that come in and finding and making a prediction on whether something's fraud or not. That's
excellent.
Hopefully
Thank
helps.
you. And Andrew, just from your focus on investing in ETFs, obviously there are companies like Google that have the resources to develop these kinds of capabilities in-house. Do you see, on the other side of the coin, are there startups that are developing these technologies for smaller firms?
If you go to any fintech conference, there's probably half the room talking about how they use AI. I think a lot of what companies are doing is they're looking at large data sets, and they're more so, I'd say what's more popular from the investment side is building cheap portfolios and looking at historical data so that people aren't taking a lot of risks, and they're finding very low cost, low fee ways of allocating their capital. A lot of them using ETFs because they are low fee. But there are so many fintech companies that are out there that are all saying that they use different versions of AI. So some of it may be looking at social media in order to determine what companies are going to outperform or which ones might have negative sentiment. There are some that are trying to use real-time machine learning, and there are some hedge funds that certainly invest a ton of capital into trying to be on the leading edge of reading these signals better than others. And it kind of has this interesting momentum effect where if everyone's using these same signals, you'll have a lot of people chasing those same data points. So it's difficult to necessarily say who's doing things the best. In the ETF world, there are some AI-related types of funds, and not all of them beat the market. So for them, going out there, it's almost like saying, okay, kind of the active management versus passive management debate. If you're an AI fund and you're underperforming an extremely low-cost S&P 500 focused fund, you're not going to really raise too many assets, or if you do, you're not going to keep them too long if you're underperforming. At typically what is probably going to be a higher fee type of product because their AI is better than everyone else's.
Mm-hmm. And besides price, what are some other challenges that are sort of preventing companies from adopting AI? Like, do people need AI specialists on their team when they have these products, or?
Yeah, well, I think that the toughest thing is building a track record. And no one wants to necessarily be the first person to invest in a product that doesn't necessarily have this great track record. So you're kind of put in this situation where a company has to launch a product before someone can invest in it, but everyone wants to see what this performance is before they jump in. So, for many investors, that timeline is maybe 3 years minimum before they could say, okay, we feel like this actually does beat it and whatnot. Or you're just looking at people's back tests, and historically, back testing is made up mumbo jumbo, and anyone can have a beautiful looking back test. So at the end of the day, are people going to jump into a new idea? And you need that performance first. So it's kind of this chicken or egg kind of scenario.
Mm-hmm. Excellent. And Ashley, you brought up biometrics, but this is a question for anyone. So with biometrics, face recognition, a lot of companies have started trying to flesh out that market in recent years. We've seen a bit of a pushback, like San Francisco this week voted to ban the use of facial recognition in some situations. We've seen similar laws being considered by Washington State, the state of California, and there's even been talk of a federal law that will have some of these limitations and restrictions. Do you think that the ethical considerations that are very closely connected to AI, biometrics, facial recognition, do you think that they have a chance of sort of freezing investment in this area and preventing companies from wanting to adopt the technology?
Everyone's looking at me. Yeah, listen, one of the things that we actually like doing at Revolution, as I mentioned, we're based in Washington, D.C., We have a policy team on staff who works with us and helps our companies to navigate some of these challenging political and regulatory situations. So, we invested in DraftKings before sports betting was legalized. We believe that there's definitely a future for this, or we wouldn't have put our money in, but it's definitely a little bit of a roadblock, which we're working on getting through now.
Excellent. Andrew, let's move on to space a little bit. I'm very interested in hearing about UFO and sort of what you see as the next frontier with cybersecurity and space. What's the intersection between those two areas?
So I think we're seeing certain areas of investment that are getting a ton of capital allocated to them. Some of the most exciting themes that people are getting really giddy about are things like Internet of Things and connected devices, cloud computing, 5G, and how amazing all of these will be for gathering data and making our lives easier and better and helping us go about our lives in a better, faster way. What most people aren't realizing, though, is all this data needs to be transferred from one place to another place and processed somewhere. And so, satellites and different ground equipment, that is, probably one of the most important parts of the infrastructure that most people don't think of. They think of, 5G, and they might think of, one thing, or they think of connected devices, and they think of, their Fitbit or their home assistant type of appliance. But really, there's going to be so much data. If people really believe in these industries, what they're really believing is this massive amount of data that's going to be created. And where is it going to go? It's going to go up into a satellite at some point and then sent back down to Earth. So if you're really believing in these ideas, I think space is something that people should be considering, because it's that infrastructure, it's that backbone, it's the toll operators that people need to send their data through in order to make their technologies work. And historically, when looking at satellites, you'd send a satellite into orbit, and it would have a set program of what that satellite was going to do. You'd know how long it was going to be in business and working for, and you know when it would essentially die off and come back to Earth or burn up. Now what's happening is people are incorporating things like AI and big data into satellites. They're talking about storing more data and putting actually a lot of the cloud and data storage into these satellites. And they want these satellites to adapt to things in real time. So before, everything could just get programmed up in the satellite and it could just do its operation and it could be done. Now they want these reprogrammable satellites so that it could do one mission and then it can move on to the next mission. Or it could have one customer and then it can leave that customer and bring on to where the next demand is from. But the real complication that's bringing is, if you can have the ability to reprogram a satellite, so could a hacker. And so actually being able to protect these satellites better, I think, is going to be a huge push for some companies to develop that software. So it's great to have a satellite that has the ability to do more and be more powerful and collect data and store data and transmit data, but really protecting that ecosystem from people that want to either use that data for their own purposes, or possibly so many satellites are being used for government and military and top secret types of projects. That being able to get into the wrong hands or co-opted is a huge area of concern, and I'm glad that there are companies that are already looking at what they can do to better protect satellites.
It's fascinating. In your introduction, you were talking about sort of the concern over fundamental hardware problems.
Yes.
And the challenges with fixing those kinds of things. Obviously, if there's a computer that has a hardware issue, you can, if worse comes to worse, you can always just throw away the computer and install a new one. With satellites, they can be up in space for 20 years or longer. What are some of the implications and possible solutions to address that kind of things, or do we just have to kind of cross our fingers?
This is a fundamental problem. I mean, you cannot replace the hardware because the hardware is out there. So if the problem cannot be fixed with firmware update, you basically cannot fix the problem. That being said, there are some mitigating factors for satellites. Not everybody gets to run their code on satellite. It's not like a cloud provider where if I can run my code on a cloud provider and I have a security vulnerability that I know how to exploit, I can start getting access to other people's data that are using the same services I'm using. On the satellite, I'm guessing only the satellite operator or a few operators have access to the satellite. And so in order to attack the satellite, you would either have to target those companies and try to steal their access to the satellite, or you would have to look into some kind of security vulnerability in the transmitter equipment on the satellite itself. And if you find, suppose you found such a vulnerability on the code that handles transmissions on the satellite, it can be either in firmware or in hardware. If it's in hardware, then it's really a problem because you basically cannot patch it if it's not patchable by firmware, or if you cannot shut down the module through firmware. Yeah, it's a big concern.
Yeah. Mike?
Yeah, maybe to hop on here, it's the attack surface we're talking about. So as a bad guy, as an attacker, you want the attack surface to be as wide as it can possibly be. So in satellites, you've got the ground station, the satellite itself, the communications link that's going on in the satellite, the software running on the satellite. As more stuff goes there, the attack surface gets bigger and bigger and bigger. And if you go even further, it's the supply chain that brought the satellite together and brought all these pieces together. Right. That those all need to be validated. As we built out at Google our cloud platform, we thought about trying to make that attack surface as small as it can possibly be, including the hardware. And one of the things we built was something we call the Titan chip, which is a little chip that verifies that the firmware is the firmware that we expect to be on the machine. And it's a piece of hardware that we manufacture and put in there. So as all that stuff comes together, it's done in a very safe way. And then we sign and validate everything that goes all the way up the stack there. So we try to reduce that attack surface. And it helps our customers trust us a bit more, which is kind of the opposite problem, which is to create more transparency for customers. So if you think about trying to build trust with a customer, you want to reduce the amount of stuff they have to trust you about. So if I'm a cloud service provider and I'm saying my cloud has these capabilities and this is something that a vendor wants to convince people around, the security community really just doesn't trust vendors or providers in a pretty big way. So the approach we've taken is to try to reduce the unverifiable trust surface. So you think about the number of things that somebody inherently says, you want to actually provide transparency. So we try to do things like provide logs whenever anybody accesses our system and provide details about how the whole thing works, provide the diagrams for how this stuff works. And I think as the attack surface grows, vendors and providers are going to realize that the more transparency you can provide into how that stuff gets put together, the better.
Yeah, and one of the things I think is kind of particularly scary is how large the attack surface is. I mean, the International Space Station has been hacked before. It wasn't connected to the internet until 2010, I don't think, and then since that point, it's been hacked multiple times, to the point actually where, at least to my understanding, much of it was tied back to Chinese hackers. And in several documents, it's been found that as they talk about improving their satellite warfare capabilities, they're describing it as being able to take down satellites as being able to blind and deafen their enemies. And so you here have both a situation where there's a lot of places you can attack both on the ground and in space, and you have a lot of wide-ranging implications because we use satellites for GPS and for phone access, power grid, et cetera. So I think it's a real issue.
Yeah. Mike, does secrecy also play a role? Since I've heard rumors that, not necessarily Google, but that some cloud servers and data centers are built underneath mountains and are impossible to find.
So our customers know where our data centers are. It's a competitive environment, so you want to have data centers as close to your customers as you can, and I think most infrastructure providers give this information out. But obviously, all cloud providers are investing deeply in the physical security of the of the data center using every technology at their hands to do so. We think we do quite a good job at this.
Yeah, just to highlight one point that Mike said before, the supply chain concerns are, this is a very, very large concern and very important these days. Probably all of you have read about this, the whole Supermicro incident, and yeah, it's very difficult to handle this. I'm very happy to hear that you're putting a lot of efforts on validating firmware. There are many other components except for the firmware, the flash that holds the firmware that needs to be validated. And,
yeah. I kind of remember that the Supermicro issue was what people were talking about at last year's conference. I kind of remember it. And I think it's still unclear what exactly happened. But I want to leave some time for audience questions. But so while people are getting their questions ready, Mike, maybe you could start off with the third subject of this this talk about cloud security. What are some of the key issues in your mind? What are the big risks, and where are you seeing the best potential for investment?
Great, and there's actually a question from the audience. I don't know if the gentleman's still here, asking about, well, hey, isn't there somebody at that cloud provider, Mike, who works for you, who could access said data? And as we engage with our customers, a big part of this story is building trust. And to build that trust, we have to be transparent, and we have to build lots of security products. So I group the products that we work on into three categories. Security of the cloud. So these are the features and capabilities that make the cloud fundamentally secure. And we talked about one of them, our Titan chip. You can think about the security of the data center, our intralinks between our data centers, all the things that make the physical cloud secure. Then we have security in the cloud. So these are the features and the capabilities that allow large enterprises to build applications in the cloud. And there's a whole universe of security products that make that work. So encryption, key management for encryption, identity and access management, all these areas are getting huge amounts of investment both by the cloud providers and by new companies that are trying to figure this out. And then we also offer security services and on-prem security. So you can think about, the cloud actually has some really interesting data and capabilities that it can deliver. So we have a product that we work on called safe browsing. If you've got your laptop open and you're using Chrome, and you go to a website that we believe is malicious, Chrome is consuming the safe browsing list and will tell you, that red screen will pop up and tell you, hey, this website you're about to go to is pretty bad. Well, that's because we're looking at maliciousness all over the web and can deliver that through our cloud to customers. And we think this is something that enterprises want more and more on-prem and in their environment. The other bit that folks really worry about when moving to cloud is, are people in the cloud provider going to access and cause problems with my data? So they want assurances, they want guarantees almost in many cases that no one in the cloud is going to be able to access or modify or change the data. So as a provider, we see a world where we do as much as we possibly can to verify this, and we have products that we think are very differentiated in this way, that give transparency in a way that other cloud providers don't. And also there's a little bit of a place for an independent ecosystem where, hey, I don't want to place all my trust in any of the major cloud providers. I want to place some trust in this independent ecosystem, this independent third party, and they're going to intermediate or broker or provide some of this well. We think that's healthy. It works in many other institutions and organizations like financial services where you don't put everything in one place. You've got intermediaries, you've got a whole group of categories. So we see that as something very healthy for the ecosystem. But I will say that overall, the biggest challenge that we see, and this isn't a statistic from us, it's a statistic from Gartner, 95% of incidents that occur in the cloud won't be due to a cloud provider's error. So these scenarios where my team gets hacked and Google Cloud has a problem are we hope very low probability, but the real cause of incidents, and you'll see it, and you saw in the Verizon data breach report and other reports, is the customers are misconfiguring the cloud. So the way we talk about it is the shared responsibility model. So if you think about, look, as a cloud service provider, we're going to provide the data center, the network, the infrastructure, the hypervisor to run your virtual machines on. But after that, it's up to you. You need to compose solutions together to build a secure environment on top of it. 95% of breaches are due to the customer's part of the shared responsibility model of using the cloud. So companies that help make that better, companies that help solve customer problems as they're migrating to the cloud, and they're a piece of the shared responsibility model, we think there's a healthy, it's a big community. We got to get together here as a security community to solve that problem.
So it sounds like don't get fooled by the misconception that shifting to the cloud means that you're shifting the responsibility over security.
Correct. It significantly helps because and it's the old story of specialization, right? We've got a team that is really good at securing data centers. It's really good at managing networks. It's really good at many pieces of the security ecosystem. And in fact, if you're consuming like serverless, we manage way up on that stack, and we take ownership of that piece of it. And because we're specialists and we're good at this, and you ask yourself as a customer, are you a company that is going to build differentiation and specialization in hypervisor security as a retailer? Probably not. So that probably makes sense to hand to the cloud provider. But you do get huge benefits from moving to the cloud just from being on common infrastructure from lots of companies.
Great. Does anyone have additional thoughts on cloud before we turn to the audience?
I think I maybe kind of mentioned it before with more companies wanting to actually store and put clouds in space. Kind of one other interesting area of why it's so important in my mind to be on the cutting edge and leading the charge with creating more secure types of satellites is I won't mention a competing cloud company, but there are other companies that are talking about launching significant amounts of satellites into orbit. Currently, there's roughly 1,800 operational satellites in orbit. These companies' proposals to send more satellites into orbit are talking about a specific company putting thousands of their own, so building entire satellite constellations and networks. And so you look at the amount of potential disasters that could happen by things like space debris when you're talking about the potential for collisions, and you're talking about putting not just the 1,800 operational satellites that are already in orbit, but you're talking about in the next few decades having tens of thousands of satellites in orbit, and the potential for someone commandeering a satellite and putting it off course and potentially creating something that could create significant amounts of debris, causing more impacts and rendering this great atmosphere for allowing the transfer of data and technology. It just becomes even that much more important and critical to protect these satellites. So I hope that's something that you're currently working on.
Questions? Let's start in the front.
Thanks. Is there any space question? Is there any big improvement happening or coming up for latency of space? We're talking about 23,000 miles, right, for geosynchronous. There's lower orbit too, right, if you're not geosynchronous. But then we got a massive latency problem. Is there any improve that?
You look at some types of technologies like driverless cars, and that was kind of talked about earlier too. So many signals and the processing has to actually happen on the vehicle, but then a ton of data will also go to space. I think so much of how we're going to be utilizing these satellites, at least maybe over the next 10 to 40 years, there'll be a ton of broadband uses, and that will be going to areas where previously we may have laid cables out in order to transfer this information. But some of these areas that have been tougher to access, we haven't already put the investment into infrastructure. I think those will be completely reliant upon satellite infrastructure for things like broadband and other communications. So I think the areas that need the super immediate focus, maybe they will use more direct cables and lines like that to help with latency. But I think everything that's being created with 5G is going to enable the faster transfer of this data. I think you obviously have certain physical limitations when relying on having to send data so far away just to receive it back on Earth. But there aren't really many better options to use on kind of a really broad scale. Maybe you'll see high frequency trading firms relying on these, paying a ton of money for various infrastructure because they need a pipe that goes directly from point A to point B, and the amount of money that they're going to make or save on transactions is going to be worth it by having that kind of direct feed. But I think maybe government and security and high level things like that. But when it comes to the consumer, I think a lot of it's going to be relying on that, and latency will be something that they'll just have to deal with.
Other questions? Right here.
Yeah, thanks. Maybe this is more of a question for Mike, but I'm an investor in early stage cyber startups, and we've been seeing just a bunch of activity in the cloud native security space, particularly around like workload identity. And one of the questions has been, how do the cloud security or cloud vendors themselves view, this like startup activity in the space, and are they building their own tools? Are they going to acquire a company that they're going to use? Are they building infrastructure that's meant to be complemented by these different components? And so how are you viewing that space? And maybe one of the other themes that we've been seeing is a lot of these big firms have like multi-cloud architecture, right? Like if you ask them which cloud they're using, they'll say all three. How does that impact the security kind of question as well?
Great. So just to repeat it quickly, there's two questions. One was about cloud native security and workload security, and the second was how are we thinking about hybrid security for large enterprises that are using multiple clouds? Okay. So on the first piece around cloud native security, there's a whole ecosystem of companies that are appearing and are taking kind of the model that the world's created for detecting anomalous behavior with workloads that we've done for a long time on bare metal, and now saying we're going to do this for hypervisors and in the cloud. I think it's very healthy. It's something that it's an approach that will find bad stuff. From the cloud provider's perspective, while we do have security business, ultimately a big part of the spend for large enterprises isn't on security. Like, we probably don't want a world where enterprises move to cloud and then have to spend huge amounts of new money on security in the cloud. So we see those solutions and solutions that we're developing ourselves for similar problems as enablers for consumption of other cloud products. And ultimately helping enterprises secure their workloads is going to engender more trust with the cloud provider. So that's on the first piece. On the second piece on hybrid meaning you're a large enterprise, you've made the strategic decision that you're going to run on more than one cloud. Our approach is, if you're a CIO and you've come to this strategic conclusion, which most actually have, you're spot on, right? We don't think anybody is going to pick a single cloud provider. We don't think that's the ecosystem that'll develop over time. And in fact, many organizations are developing using cloud approaches on-prem. So if you look at the global IT spend, I don't know the large number. It starts with a T, and I won't try to estimate it and get called on it. But it's a very large number. Maybe 10% is in the cloud today, and it's growing. But the on-prem spend is also growing, and it's growing rapidly. So this is a very, very big market. And there's a research organization called 451 Research that says 44% of large enterprises are trying to modernize in place, which means take lots of the concepts that the cloud are using and figure that out on-prem before moving to the cloud, because they're concerned about all kinds of different topics. We see a world where enterprises modernize a little bit more in place and then work with many cloud providers to run their business. And from a security perspective, our approach and many approaches that are being taken are to help enterprises secure on-prem using cloud approaches, and then build frameworks that they can adopt across multiple clouds. Google has one called Kubernetes, for example. It's open source. We love that the world is adopting Kubernetes and our open source approaches, because they're going to run it on-prem, they're going to run it in our cloud, they're going to run it on competing clouds, but it's going to up-level everyone to a place where security is better and enterprises can trust themselves, trust the workloads more. And ultimately, we're able to compete on what our core benefits and assets are. We think we've built a very secure infrastructure, et cetera. I hope that answers your question.
Thank you.
Well, thank you all. Would everyone please join me in thanking the 4 amazing panelists for a great discussion? Unfortunately, that's all the time that we have. Thank you.